So last week I said I was playing with my I played with my telemetry radios enough to know that they do seem to connect to each other, and I just by using Putty terminal at both ends I could send data back and forth. And I started to figure out, because various things come up. How do I know that the data is valid? And what was the other thing I wanted to do? Oh, and then do range checking, which I haven't done any range checking. But so this week I put the thing back together and thought, okay, how can I verify that data? So I had the two radios plugged in the same laptop, just over the USB cables, and I fired up the RTKlib ntrip client. So it's just a command line you type in. It goes out the internet, grabs the correction data, and shoves it out one of the serial ports, which goes to one of the radios. And then the other radio picks that up. And by watching that in Putty, I could see the data going by. And I think at one point I was doing that, and I think I said, okay, I'll turn on logging and put the received data into a file. And I went and looked at it, and it's binary data, so you can't really tell what it is. So I went to back to RTKlib, and they've got a conversion routine called convbin, convbin, and you start that up and give it that binary input file you just received, and I think you have to tell it the type of data. So you have to say it's RTCM3 data, and you run it, and it extracts it out, puts it into a text format so you can read it. And I went and looked at that. It looks like the first time I ran it by using Putty, it seemed to give me some data, but the something about the distance to the antenna wasn't filled in. I thought, oh, I could go back to RTKlib and use their stream to stream utility and say connect. The input stream will be the port from my receiving radio, and just write that to a file. So I use that to grab the binary data, and I started up the stream to stream to give me the correction data, pushed it out the radio, came back in the other radio, and used the stream to stream command to say take that and write it to a file. When I did, then I said take that binary file, I converted it, and then the data all looks right, and it wasn't complaining about anything. So I thought, well, that's a good sign. And so the ultimate thing would be wired up to the vehicle. Speaker view. And what I did was I took one of the two radios, and it's got this, because these radios have both a USB port and just a 6-wire connector on the thing. So I just simply took this happens to be, I just took an old USB cable. Actually, it's probably a brand new USB cable. It's one of those I bought at Dollar Tree, and at the time I was paying $1 a piece for them. They've raised their prices. They're $1.25 for everything now. So anyway, I just soldered that on there, and I just inside of the cable I've got the individual wires. I put heat shrink on them, then I put a couple layers of clear heat shrink over the top to hold the whole thing together. And then the other end I just have it's got the USB. It's got the USB cable with the 4 wires, and I put clear heat shrink on each of the 4 wires, and then again put 2 or 3 layers of clear heat shrink over the top. And the wires over here are just the jumper wires that you can buy everywhere, and I just cut them off to do that. So I got a power to ground, and then there was the transmit and receive. And I was originally going to use this wire, which is some kind of sensor wire. That it's fairly flexible. It's much heavier than the USB stuff, but it's got the brown, blue, black, and white. And I thought, well, I don't have to figure that out each time what those colors are. So that's why I went back to the USB cable, where it's got, inside of this. So it's got a red and a black wire, and then it's got a white and some other color, white and green, I think is the colors. And those, once I got these wires, the jumpers put on the end that are color coded, what I know, I guess it didn't really matter what was inside of the cable, but this worked out well. So it's just a way to get some nice flexible wire that worked out to make the thing work. So I just went into my robot and just disconnected my ESP32 board that normally gives me, as part of my whole correction scheme. Just unplugged those 4 wires and plugged these 4 wires in, and turned it on, and it fired up and was running. And let's see if I go back to, well, I'm not uploaded this one yet. So let me go back to, oh, it's here. This one. So let's see, how do I do this now? I gotta go share screen. Share screen. I think it's this one. So assuming, what, that didn't work. Let me calm down a second here. Let's see what I got. I got to back off here. So this is the thing I posted on Slack saying I've got the thing running, and there you can go into the F9P receiver, and you can see the screen, right?
Yeah.
Let me change the viewer view. Okay, so you can go in there and you can turn on this mode and say, show me the incoming correction data. So in the middle of the screen here, assuming you can see my cursor, it lists out, these are all the different correction messages that are coming in. See, these are coming all the way from the Department of Transportation over the internet and through my radios and showing up on the receiver. And here's all the messages coming in. And this column says CRC passed, and you can see the total, and it says the ones that passed are the same number. Over here is the ones that CRC failed, and they all say 0. So that told me this stuff is probably working correctly. Everything is coming through like it's supposed to. How do I move this? Well, oh, there we go. You just drag it. So this is this particular one happened to be out in the front yard, and over here you can see the fixed mode on the right says 3D DG and SS/fixed, which means I have an actual fixed position. I was sitting fairly close to the house, so it took a long time to lock on, but it was working. And so that says, yes, it's working there, and come back over here. And this is the ground plot. And I still haven't figured out to this day if it says 0.1 meters is the outer circle. I don't know. I still don't know if that's radius or diameter. And either way, it's a fairly small grouping of points over here. So that was working fairly well considering how close to the house I was. And it all seemed, that told me that yes, the stuff is going, the correction data is going through. I get a fixed solution, and I get a nice grouping on the ground plot. Then over here on the right, here's the thing that's showing me the satellites that they can see. So all the ones with American flags are the American GPS, and then this is the Russian flag, and this is the Russian GLONASS satellites, and down here is the European flag. It's that European Union, whatever it is. It's the European satellites. That's the Galileo constellation system. And these down here, they're popping in and out for whatever reason. I don't know why they're doing this. See, that this is a thing that slides by, so it slides to the left as the new data shows up. So if you're looking at it, I guess you put your hand over, here's one up here. You can see this one's kind of going up and down for whatever reason. I don't know what that is. And for some reason, these are just simply dropping out completely on the Galileo stuff. And I didn't know what was causing it. I thought, well, maybe the radio is causing that. So the next day I turned it back on and tried putting the radio next to the GPS antenna. It didn't really seem to make a difference. One of the things dropped. One of the satellites dropped somewhat as I got close to it. But I think just because my hand was in the way, blocking the whatever satellite from that direction. And I finally decided, no, the radio, it doesn't seem to be affecting the GPS. So then later, let's move on. See anything else? Any questions on what I got shown right here? This is just simply the
GPS. Physically connecting. So you've got correction data coming in from the internet. How do you get it from the internet into that radio? What are the pieces connecting that?
Well, I've got physically, I've just got one of the radios with a USB cable packed. Here's one right here. Let me do this. So here's one of the radios, and it just got a USB cable plugged into it. So I just plug this directly into my laptop, and that gives me my physical connection. And
that's your laptop's running Linux or Ubuntu or something.
My laptop is running Ubuntu Linux, and then I fire up the utility from RTKlib, which is stream to stream, is STR to STR. And I was going to pull up and post what that looks like. Email. Open this one. Stream in to USB 0. If I take this, copy, And how do I get my, oh, I don't have my chat open. No wonder I can't find my chat. So here's my chat. Where's my chat? Here. Type this here. You know, if I change my password to the word password, user ID. Okay, we'll try this. So hopefully it's not too incriminating. So if you go look at the chat, that's basically what the command looks like. For some reason, my text is really giant. I don't know. I don't know why it is. But anyway, so you entered that command, and the stream to stream is the actual program that runs. And then you say -n specifies your input stream. Let's see, how can I do this? I should be able to put this over here. Go back and share my screen again. Do this. And let me, well, we'll just leave that stuff in the background just because. So I guess it's good now that I have giant text because we can see the whole thing. So the str to str is the actual command that runs. -n is specified in the input stream. And from my input stream, I say ntrip, and then I give it this is the URL, or no, that's not. This is I have to put in my user ID, and I put in my password. And then over here, this is the URL of the DOT, the URL of the DOT out on the internet, and 9,000 is the port number. And that when you sign up, they tell you all that kind of stuff. And the next one is they call that the mount point. And the mount point is basically points into the database and tells it what kind of data to send you. And the one that says RTCM 32 is the newer one. So that gives me GPS and GLONASS and Galileo correction data. And if I change that 32 to a 31, I just get GPS and GLONASS, which is what I'm going to do here in a second. And then so that tells it what kind of data you want to receive. And then the RTCM3 says that's basically the correction data. And that's something about as they do conversions, they need to know that. So then the -out is the output stream. And you can either send it to a file, you can send it to a serial port, you can send it out the internet. There's all kinds of stuff. This thing's really flexible in what you can do with it. So the output stream says we're going to send it to a serial port, which happens to be TTY USB 0. And since it's a USB 0 port, I have to have the baud rate correct. So it's running at 57.6 kbaud, which is what the radios default to. And then this number here, I just simply said the -p. I don't know why it's called P, but that basically I have to tell it where I'm at to get this stuff to work. You can either have the GPS receiver can send back like a GGA command to you, and then just pass that on to the DOT. But the way the software is written, I can't pass data. I can only go one direction with this. So I just put in I say the -p says I want to just blatantly tell you where I'm at. So this is just a point out in my front yard, this latitude and longitude. And then this 235 is an altitude in meters. And then the -t, I forgot what -t was. A -n, I think, is the speed. So I think it's going to give me samples once a second, I think is what that's telling me. So that just occurs to me. If I change that to say 5, then maybe it only gives me the correction data every 5 seconds. So I'm sending less data, and I'd have to verify if that's what it's doing. I'd have to verify that's going to keep the thing happy at that point. So anyway, I just simply execute this command line. It connects the internet, gets the connects to the internet, this URL here, and it shows up with the correction data. Where it says -out, if I just leave that off completely, it just shows up on the screen. So it just dumps it on the screen for me. So I can either say dump it on the screen or send it to the serial port or create a TCP socket. And
excuse me, Jeff, is there another screen you're supposed to be showing? Because you're still showing us the messages UBX RXM.
You probably haven't heard this for a while, but boy, I hate computers. Let me do this. And let me say share screen. Why doesn't that show up? It says screen 2. Now can you see it?
Jess has started screen sharing. I saw your
Oh, it just showed me picture.
solitaire, and now it's showing.
Solitaire. Huh.
I didn't see solitaire. I just am now seeing I think this is ntrip.
Yeah,
graphic
now
screen.
I'm seeing the ntrip. Yeah.
Okay, so anyway, just briefly do this again. Here's the str to str is the command that does all the stuff. You've got an input stream defined by -in, and you got an output stream defined as -out. So on the input stream, I can either say take it from a file or take it from a serial port. Take it from, in this case, I want an ntrip client, and then I specify my user ID and password, and here the min cores dot min, that's a URL out on the internet. So if you type that in, it'll pop up. And I think if you type that in, I think it takes you to the actual site. It's not the correction data. And then the 9000 is the port on that particular URL. And this big block here says RTCM 32 NAD 83 2011. That is a mount point.
Just so you know, Jeff, I'm understanding what you're talking about because I'm looking at the chat and looking at the command, but where your cursor is, we still see the message type, total count, CRC passed, CRC failed data from your ntrip screen.
Let me do this then. What does this do? Let me try this. Stop share. Share data. Screen 2. Why doesn't this work? What is
Slack?
There, I see your Slack screen.
you see which screen?
Slack.
Okay, well that's not what you're supposed to be seeing. Oh wait, we can I guess we can go with that. I think I posted that. So for some reason it says meeting chat to everyone. Oh, apparently you can't show the chat screen. Oh, so I don't think I can show the chat screen or the participant screen. So let's do this. Random.
The str to str command, who gave you that? Is that open source or is that?
That comes with the RTKlib package. Did I chat? Well, here, let's just cut through the nonsense. I'll just post this directly to Slack because I don't know what's going on here. So let me copy that. Go over here to oh, of course, it's not going to show up big. So anyway, I'll do this. Now, how do I get this to Control plus? Does that do it? Okay, now can you see a message that says
Yes.
str
Spring in. STR to STR.
Yeah. Okay, so I've been through this several times, but yes, this is a command that comes with RTKlib. This is what they call the command line functions. Now you can also just download the binary. You could run this under Windows if you want to. And for some reason, the names are different. They've got another one. I think it's called Stream Server or something like that, as opposed to str to str. So there's the command line stuff, which is what I use under Linux, or if I go to my other computer that's got Windows, I could theoretically run that. It's got a GUI that pops up and you fill in all the little boxes with all this information down there. So you can make it work either way. So this is just a convenient way to, this is how I get my correction data, and this sends it out my serial port, which I see is highlighted nice in blue color now. So that's how I do it. I just fire up this one command line, it connects to the internet, gets the data and sends it where I want it. And I say, send it out the serial port, it goes right to the radio. And at that point, I'm now publishing correction data. So now on the other end, let me see if I can do this.
Just so I'm understanding, What is the dash P?
Dash P, let's see,
I am here.
I'm
It's-
specifying, you can either send your location back to the DOT so it knows where you're at, or you can specify right in here. The dash P means I'm gonna just blatantly tell you where I'm at. So it's just an absolute position. So I just went on my front yard and took the latitude, longitude, and altitude and just type them in here. That's what that's doing. And if I weren't using this particular command line, I could have apparently I can have the GPS on the robot send the GGA command, which is a NEMA thing saying this is where you are, have it send it back over the radio and then pick it up there and then send that back to the DOT. But right now, this works if I just tell it. I
Okay.
think all this is for, it just knows which antenna site in the state it should use. So it just picks the closest one. So you just have to get that. I could probably trim about 5 digits off that and just say, okay, it's in this general area. And that's what that's for. That's just saying this is
Okay. I didn't know if it had to be exact, and therefore if it's floating, that your corrections would be floating. But okay, that tells me what I need to know. Thank you.
No, I don't think this is actually specifying. I don't think it's used for anything other than to say, this is the data we're going to send you. And so it goes out, because this thing with the, I said it's called the mount point, this RTCM 32, whatever. That is telling it which data you want, and it just needs to know which site, because there's an antenna down at the airport, and there's one that says it's in Arden Hills, which is the one I think I'm using right now. And then there's one over west, over by Plymouth somewhere, and I can't remember what the name of that one is. But by giving it this location, it just says, oh, this would be the closest one. I think that's all it's using that data for. And so anyway, that's that command line will do that. And then I was going to pull up my next one here. Let's see.
And then you're gonna run this on a computer that sits still and is your base station, or are you gonna run this on the computer that's on your robot?
This is essentially my base station, and it doesn't care if it's still or not, because it's just taking information from the internet and putting it out on the radio. So I could either, have a laptop in my house connected to my home network and then stick the radio out the window, and that will work. Or I could take my one of the radios and say, take one of the radios and just wires hanging out. I could connect that to my little ESP32 board that's in this box right now. I can pull that off and connect it directly to this, put a USB charging battery, and I can just put a magnet and stick it on the top of my car and turn it on. And that way that will connect my access point in the house for Wi-Fi. And then it's got software to do the ntrip stuff. And then it will talk directly to the radio. And that's another way I could do that. And of course, another way is to connect, take one of the GPS receivers off this thing, take this one off, take the front antenna off, and take the board out of here, and put those on a tripod and connect it directly to a radio. And again, put a USB charging battery on it and just stick it out in the yard somewhere. And that could form a base station, and I generate my own correction data. So that's like what you're doing right now. So that's, there's lots of different ways to do that. You just have to get correction data and ship it over the radio to the vehicle that's sitting over here, to this vehicle right here. So let's see, I'm totally lost on what I'm doing here now. Let's see, I pulled up, go back to my email. Is an email. Back to my email. Yeah, here we go. So then I did, well, here, let me just put these in, and nobody's going to know what I'm talking about. But anyway, I'll do this anyway. Let's go to here. Let me go back to Slack. So this one is the one where I've connected to the Department of Transportation, and here under out, instead of saying serial port, I said file. So I'm just simply,
We don't see a Slack screen.
oh boy. Well, isn't that interesting? Let's see. Do this. Do share screen. And let's see. Slack. Let's try this again. Can you see Slack now?
Roger that.
Okay, so where was I here? Okay. So this one, this is the this again, I'm using the same command. The input stream is the same. It's still going out to the Department of Transportation and getting the correction data. But now I specify out. I say put it into a file instead of putting out the serial port. So everything else is the same. It's just the destination says write the binary data to a file called RTCM3.bin. So when it does that, it just takes whatever's coming in and creates this binary file. And let's see. So I'm gonna go here and go here. And take this one, control copy, come back to Slack. Type message here. I guess I'm live here. So this one, this command, this is another the utility functions from RTKlib. So convbin says convert the binary data. So you just simply say you run that command, you give it the binary file name, and the one I had up here said where to go serial. Meeting chat. Oh, I got the wrong screen here.
I was gonna say, I still see your old.
Yeah, how to get Slack to come up here? There's Slack there.
That's still the old one because I see your file : //
Okay. Oh, good. It appended them together. So anyway, here's the command from RTKlib, this convbin command, and you specify. Can you see that?
Yes.
Okay, so you specify the binary file that we created earlier, and before I called it right above here, it was called RTCM3.bin. This particular example said USB1.bin. That's just the binary file, and the -R. I don't know why they call it R, but that's the file format is RTCM3. So you run that, and it generates. Oh, is this worth doing here? Go back here. Ops3. This might make a real mess here, but I'm gonna try it anyway. So we go over here, come to here, paste it in here. I say, oh, it did paste it. And I guess I don't even actually, since you can see on the screen, I don't really have to post that out to I wouldn't actually have to post it to Slack, but I'm going to do it anyway. So that should be out on Slack. So when you're done, when you run that command, it takes the binary data and gives you this is called the header up here. So it's telling you all kinds of fun things. It says this is the approximate XYZ location of the antenna. So if you could figure out how to decode this is probably meters from Greenwich Mean Time or whatever the default for GPS location is. This is telling you how many meters, how many million meters you are from the antenna. And then here's other stuff up here telling you somewhere it'll tell me the see Trimble alloy. So Trimble is the system they're using to generate this with. And I thought there was something else fun in here that would tell us somewhere in the binary data, it gives you the actual name of the location of the antenna, and I don't see that right offhand. Mixed Linux run by comment log data. So anyway, there's header data on there, and you get all the way down to here. And this is a timestamp. This is your first sample coming in. So on 5/16 of 2023 at the time 1944 and 33.0 seconds, you got a burst of data, and from here down to the next timestamp. We'll keep going here. There's the second timestamp. So all this data in between is information coming from the different satellites. So right here, E, I believe, is probably stands for European. So that's the Galileo satellites. R probably stands for Russia, which is the GLONASS satellites. And then down here, the G is the GPS, which is the American satellites. So see, I'm picking up a whole bunch of satellites here. And the whole point of this was just to convert the binary data into something I could read and see if it would complain. And all this seemed to look reasonable when I looked at it. You know, it's not it doesn't seem to be stuff missing, and the numbers kind of follow along, you know, from one to the other. So I decided that's probably working okay, and that's where I decided to then move on is wire it directly to the vehicle and try it out. And that's, you know, that's when I was doing the pictures. Let's see, in random. So this is the one after I converted, I went in, I turned off the Galileo satellites, and it calmed down a lot. I don't have a lot of crap popping in and out here. And I also went back to the correction data. I picked the older correction data that does not have the Galileo. So I'm not pushing as much correction data over the radio. And this has a float solution. But again, I'm sitting inside of my house with stucco on the side that has a wire mesh in the wall. So I was pretty pleased I was getting any signals at all, as I'm picking up GPS and GLONASS satellites. And here, this is a wider spread than I had, but also I don't have a fixed solution on it. So this is telling me that, again, if I display the thing with the incoming correction data, it says I have no CRC errors. So it all seems to be working fairly well at this point. And as far as on the robot end, I just simply have, you know, I've got this. Let's see, stop sharing. I just simply have this radio with the transmit and receive and power and ground, and this end is plugged right into the GPS receiver. So there's no extra processors or anything in between there. It's just feeding data right into the GPS, and everybody seems to be happy at this point. And it's the only range checking I did was I started off with my robot parked inside of my house, right inside of the front door, and I had the laptop in my living room running, just broadcasting correction data. I went downstairs, hooked it all up, and much to my surprise, it seemed to be working. So then I picked the robot up and pushed it out in the front yard, so it's, you know, like 10 feet away from the house or something. And I was still getting decent data, and that's where I got the fixed solution. So it goes at least that far without, you know, without doing anything special. So I need to just run a cable out my window and put my base station radio, just stick it outside, so I don't have the mesh, the wire mesh between me and the outside world. And then what I want to do is come to this vehicle here. I was going to mount the thing vertically here, so the antenna would be sticking up on the side of my roll bar there, and then just the wires just run down into actually it's the top box. It's not on there right now, but the wires just run into there. And I was trying to figure out, how can I verify the range? And the simplest way is just fire it up. And I guess if I fired the thing up and put the laptop on it and say log all the data from the GPS into a bag file, then I just drive up and down the street and then come back later and say, you know, plot it out and say, did I have a valid signal the entire time? That might be one way to do it. And it would be nice to do that because the GPS knows where I'm at out in the world. And then if I lose the correction data, I know exactly where I was at in the yard or on the sidewalk when that data stopped coming in. So that's one way to do it. Otherwise, you can run the you can put it in command mode or debug mode, or the configuration mode, and I can say, tell me the signal strength. But by doing that, I don't have any way. I don't have a convenient way to log that, and even if I could, I don't have any location information attached to that. So it might be easy to just simply hook it up and drive it up down the street, and if it works, then say that's close enough, and then not worry about it beyond that, so I can move on. Because if you run the Mavlink protocol, they've actually got different command packet types, and one of the packet types happens to be the RTK correction data. So if I were to figure out how their stuff works, I could build a packet with my correction data coming in and have it send that. And at the same time, you can send other types of packets back and forth. But for right now, I'm just using a serial port replacement. So I just simply plug the thing in at both ends, and I put serial data in one end, and it comes out the other end, and everybody's happy. So that for the moment, I'm just going to go with that and see what turns out on that.
Jeff, how much does the correction data change from second to second?
I don't know. One thing I do know is if you're driving around, you got good correction data, and you lose the correction data completely, it takes it like 30 to 60 seconds before it says, "Oh, I give up. I don't have correction data anymore." So I don't know. Actually, it shouldn't be changing a lot because it has nothing to do with your vehicle itself. It's the difference between where the antenna is physically located. You know, they got this big tower stuck up somewhere,
Right.
and it's that exact location, and it says it compares where it thinks it's where you told it is to the actual data coming in. It just gives you offsets from that. So I don't think it has anything to do with my vehicle itself. It's just simply saying this: if you take this correction data that we generated over here and apply it to your vehicle, that will make your vehicle will then be happier. Is that
So
what you're asking?
what I'm really asking is if I lose that radio connection for 30 seconds, is that going to be me? Is that going to make the GPS, the uncorrected GPS, or the GPS with old correction data really bad?
What it will do is if you have any kind of anomaly, say put your hand over the top of the antenna, or for some reason the correction data is not coming in, the first thing it'll do after a certain amount of time, and that's so many seconds, it understands it has no correction data, and it'll drop from a fix solution down to a float solution. So it's better than just a normal GPS, but it's not as good as the fix, and it just automatically does that, and it puts out status saying that it has done that. And then if you lost your correction data completely, then it'll drop from a float back to a I think I call it 3D fix. So there's like 3 different levels you can get out of this, and it gives you enough status so you know something has happened. So if you're tracking all that stuff, you can decide what to do with that. Either, you know, if you got a big vehicle like a tractor out of a cornfield, you know, if you say, "Oh, I just lost my GPS fix," the safest thing to do is just come to a complete stop and wait for the data to come back, because of it. You know, sometimes this thing just, you'll lose it for several seconds, and then it'll come back and everybody will be happy. And there's other times where the data quits, and 3 days later they say, "Oh, we noticed our stuff hasn't been working for 3 days." So then they'll go ahead and fix it and turn it back on. So when you get free from the government, you can't guarantee it's always going to be on. So you got to keep that
You
in
get
mind.
what you pay for.
Basically, yeah. And depending which site it is, sometimes they're real good about saying, "Oh, we just lost data. We're gonna work on that." Another, as I say here, they just seem to say, "Oh, well, we just noticed 3 days ago the thing stopped working, and we just finally got around to fixing it." So that's one of the problems. Now, if you're doing like Al is doing, he built his own base station, and he's not relying on the government or the internet or anything else. He just got a box sitting in his yard that's generating the correction data and sends it to his vehicle as he drives around the yard. So that's a, you know, he doesn't have to worry about it dropping out like that, but he's got other problems, as his own communication links, or for some reason the satellites may do something funny, and you still may lose correction data. But so it's really a matter of, you got to pull the data out of your GPS and say, what's the status? Is it happy, or is it complaining about something, or whatever?
Okay.
And another thing I noticed was, this is the here's the 2 different types again. Here's this is called a Hobby King version 2, and it's got the big long antenna. And the other one is, I don't know who made it. It's just another generic one that, if I put the two side by side here, see, it's got a smaller antenna on it, and it's got a USB plug on it. So I can plug that right into a laptop. And it turns out this one will talk to this one, at least if you're running the raw data. If you got a raw data format, they'll talk to each other. And I assume, I didn't verify it completely that it's all working right, but I think that will work. Now, if you run the Mavlink protocol, then you have to have the firmware version on both boards have to match in order to get all, so all the protocols line up. So that was another option that you can use this little one that's got USB on it directly, and then the matching little one on that. they actually say air on it, which I don't know if it matters or not. It's just simply that the one that says air has the TTL wires coming out, and the other one, did they mention on, where did that go? It says ground. So this one says ground here, and I don't know if there's it. I don't think that it cares. It's just the ground has a USB and the air has TTL wires on it. Because using this kind of board, it doesn't seem to matter which way I do it, and this one has both the USB. It has both the USB connector and the 6-pin TTL interface. Another thing I was wondering about, I wonder if those two interfaces are separate, or if they're just in parallel inside, because it could be I could run, say, the USB and put it in command mode and say display the RSSI, and then the TTL one down here could be going to the, say, the GPS. So if those are two separate interfaces, I might have a lot more flexibility here than what I think I have right now. Because in order to get the RSSI stuff, you have to put it in this command mode, and then it stops talking to the outside world. So again, that's something to look at in the future if I want to make this stuff work better or get better information out of it. For right now, it's just a matter of bolting it on and turn it on and hope it works. So that's what that'll be my next steps on that if I get that far. So I'll physically. Oh, the other thing I was going to point out is if I take this device here and have it so it's pointed up on the, there's a board here on the side. What I can do is I can take this little 1/2-inch cable clamp and put on here like this, and bring it down around where the connector is, and just bolt that to the side of my board. That should hold the top of it, and then the cable coming out the bottom. If I get a little, there's a small cable clamp. I think it's a quarter-inch cable clamp. I know I lost my. How do I keep losing everything? It's right in front of me here. There it is. So I can put this around the wire and do this without smashing anything here. So I can put that on and then screw that to the board down there, and then put the big clamp at the top. So basically to mount it, I could just do like that, where it has the one clamp at the top that holds it tight, and then the clamp at the bottom holds the wire, and then hope, do it like that. So I got some slack so I don't rip the little tiny wires out. And then it's just a matter of running the other end in and plug it into my box, and that should keep everybody happy. So that should be a fairly easy way to mount it. And I think I've decided that radio does not affect this antenna here, which if it did, then that would be a real problem, because then none of this would do me any good. So
Okay.
that's kind of where I want to proceed on that. The other thing is I just got an email from RG Simple a few days ago that said, oh, we've got something called a GNSS Master, which is an app you can download and put on your cell phone. And they claim this will connect anything to anything. And one of the options, it says, it's like that stream to stream program I was just talking about, where you specify an input stream and an output stream. On this one for the phone, you can say, I want an ntrip client, and go out and connect to my correction server on the internet. And then for output, you can have, it says Wi-Fi hotspot, or you can have USB serial, or you can have Bluetooth, and I think there's something else you could have. And it turns out, since I was cheap and went with the track phone on my cell phone, they say, oh, your data plan doesn't cover using hotspot or Bluetooth. They didn't mention the USB, so I'll have to find out if that's going to work or not. So I'm thinking that it could be that it's smart enough that if you load somebody's app that they're trying to talk directly to the USB, that will bypass anything that the track phone has done to me. So I went out and ordered a USB-C on the go adapter cable that will plug into my phone, and then gives me a standard type A female connector. So then I can plug anything I want into that. And then I've also got the option, so I can try that and see if that is smart enough to bypass what TracFone has done to me. And if I can, then I can just plug in a, here's one of those little FTDI connectors. So if I just run a USB cable from my adapter cable and plug it into here, it's a mini connector, then these wires can hook right up to the GPS. So that would be another option I could use. And I don't have to have a radio to send stuff back and forth, because the cell phone connects to the cell phone network and should give me the correction data that way. And there's also an older one that's been around forever called Lefebvre, Febure or something like that. And that's a guy's name, I think. And he wrote something that does basically the same thing, that it goes out to the internet, gets the data, and then it will connect to either the USB or he has several options too. And it could be that if I get the USB to work on my phone, that will indeed let me run either one of those two as a source of correction data. And that way I just simply turn it on and it connects directly to the cell phone network, and I don't have to have any other computers or radios in between. It should just basically be back to where I was, where I had on this one, I had my cell modem hotspot was stuck to the top of the laser here with a Velcro. And then inside this box, I got an ESP32 that it connects by Wi-Fi from here to the access point over here, and just simply turning everything on, that would work. But then when that was Freedom Pop I was going with, and they screwed me on that when they shut down the 3G network. It turns out apparently the SIM card I had was running under 3G, and that apparently just all quit, and they weren't smart enough to fix it, or they didn't want to fix it. And I finally just canceled that, because there's no point paying $7 a month for something that doesn't work. So that's why I'm trying to figure out some other way to do this now. I either need to do, these kind of radios, or get my cell phone connected directly to it, or I could even run Wi-Fi, because my little ESP32 cam board, I believe, has an external antenna connector on it. So I could put, run a coax out and have a Wi-Fi cable stuck up in the air, or a Wi-Fi antenna stuck up in the air, and possibly get enough range to go drive the entire, at least my front sidewalk, all the way from one end of the block to the other. That might work. So, again, I've got lots of options here. I just had to find something that works, and works most of the time without a lot of screwing around.
Okay.
I thought there's one other thing I was going to talk about that I'd looked at, but I can't think of what it was now. So I've got the telemetry radios. Or I can do it by Wi-Fi, or I can do it by, if I get my cell phone to work, or if the other option is go back to that cell modem hotspot box and order a SIM card and an account from somebody else, and I could be back in business doing that. But this stuff is, I can't figure out how any of this stuff works. You got the different networks. You got AT&T and Verizon and whoever the other ones are. So you got to get that correct. And then the box, because my box is made by AT&T, so I assume I have to go with the AT&T network, and the AT&T uses GSM as opposed to something else. And I can't get all this stuff straightened out to know, can I just order this and plug it in and it'll work? So that's another whole thing. I keep trying to figure that out, and I keep thinking that's why I want to go with something else and just get rid of that, because I don't understand how any of that stuff works. So other than that, that's just what I've been playing with. And
Well, you obviously made a lot more progress than I did.
okay, let's hear about your progress.
I could not get Ubuntu to dual boot onto my my Asus computer, which was my old Windows laptop. But then Sunday, I was celebrating Mother's Day, and my mom says, "Do you know anyone who could use your dad's old computer that he got a year and a half ago? It's an HP Pavilion X360 with 8 gig of RAM." And I go, "I know someone." So I finally got past the secure boot and was able to get Ubuntu 20.04 loaded. And now I'm having to get all of that reconfigured and then get ROS and TurtleSim loaded. So that's my goal for this week.
Yeah, I'd forgotten the modern computers also have that secure boot, some by UEFI or whatever. That's another whole day of trying to track that down. And finally, I just went into my BIOS and turned that off completely, and that's how I got around it. There may be better ways to do it, but that was the quickest way for me.
I didn't want to do that on my brand new computer, which is an HP, and I saw lots of complaints about that. Whereas on my dad's computer, nobody's used it for 6 months, and all he ever did with it was play solitaire. So I've now got it as my Unix box, my Ubuntu. So, and it's currently got 8 gig, but I've got my the 2 8 gig chips that I'm going to see if they'll fit in this box, because it can go up to 16 gig. So
Be careful about just assuming see if they'll fit, because just because it's got the right number of pins doesn't mean it's going to work. So you have to look it up and say, is it DDR3 or DDR4, DDR5? Go
well,
to the actual specifications of the computer and tell you what you need, and then look at those chips and see if they're the right kind of stuff.
it's the chips that came out of my new HP, and hopefully it hasn't changed that much in a year and a half. I know that's an assumption, but
Now, this stuff all changes without notice. So yeah, make sure you look it up before you start swapping stuff. I don't know if you could do any damage or not, but make sure make sure you get the right stuff to put in there.
yep. But that's all I've got. I start my new job on Monday. So
this new computer, what's it got for USB ports and all that kind of stuff?
the new Unix one has, I believe it's got 2 USB ports and 1 USB-C port. And I've got one of the USBs already used for the wireless mouse. So I may end up having to get a port expander for it, but at least I've got a minimum of 8 gig RAM, and I just, from the little bit I've played with it, it runs so much faster than the old computer that I had loaded Ubuntu on that had only 1 gig of RAM.
Something else that just reminded me of, because it just bit me last night. When you go to install Linux, it'll say, do you want to swap space? Yes or no? And it says, oh, okay, I'll just make one up for you. And back in the old days, they'd always create a swap space that was the rule of thumb was make it the same size as whatever the memory you have in your computer is. But over the last few years, they've started defaulting to a 1 gigabyte swap space instead of, say, like in your case, you're talking about 8 gigabytes or 16 gigabytes. Instead of doing what they're supposed to do, they put a 1 gigabyte swap space on there. And last night I was opening a bunch of YouTube windows or whatever, and I went to look at my thing, and I noticed both of my lines. There's one line that says the amount of memory used and the amount of swap space used, and they're both right at 100%. I thought, uh-oh. So I started closing down Windows, and I didn't catch it in time. I had to sit there for like half an hour for it to clean itself out, and eventually caught back up again. But that's something else that
okay.
If you dig for that on the internet, that's, oh, here's how you increase it. You type in a command line, and basically, I think it deletes the swap space and creates a new one, and you tell it. And out of frustration on my other computer, I just made it a 32 gigabyte swap space, and it never fills it up. But I don't know what other problems that causes if you get it too big. But that's something else that it'll just come back to bite you very quickly when if you're just doing random browsing and you got a lot of windows open, your memory goes up and up and up. It all says, oh, I need to swap some stuff out. So it pushes a bunch of stuff into your swap space, and it just keeps getting bigger and bigger. And once you close all that stuff, the swap space never seems to come back down. And I can't figure out how you clean that out. But that's just one more thing to annoy you, that it will come up, and it's real annoying when that does happen.
I imagine it is. I will keep that in mind.
Somebody should make a list of all this stuff. So I say, oh, here's what's going to bite you, and here's how you fix it. So, but I'm too lazy to do that.
It would be a long list.
Probably, yeah.
My progress has been focused on radios as well. Trying to get my 2 ESP32 boards to talk quickly back and forth to each other. Again, the problem that I was solving is it was all working, but the main loop wasn't processing very quickly, and it was getting hung up on the LORA related function. And so at the moment, I've got a couple of programs out there that I've posted, and they're running. The main loop runs, extremely fast, and the amount of throughput that I'm getting, if I measure from a complete cycle is sending from the radio control to the tractor, and then from the tractor back to the radio control. I get, as I mentioned in Slack, about 20 messages every 10 seconds. So it's right at about 2 hertz, which I think will be doable for me. The main change in this is that the library that I'm using, which is Grome's RTKlib library, has this function where it's monitoring the DIO 0 pin, and when that goes high, meaning it's received a packet, then it's not blocking, it's waiting for that interrupt to kick in. So that made my process run smoother. The other thing that even with this library and using this interrupt function, I found that in his library, where's my receive? So there's a receive. This is a read data function. This function operates more quicker than another. He has just a radio dot receive function, and that one is expecting a byte array, and so just reading a string for me seems to be faster, because I was getting a lot of timeout errors when this command was the radio dot receive function, and it was receiving the byte array. So switching to a byte array then, or switching to a string, because I have my data in these two structures, one for the data coming from the tractor and one for the data coming from the radio control, then I've got to change. I had to write 2 new functions. One to put that data into a CSV format, comma delimited format, and then one to unpack that. So that's been what I've been working on. So at the moment, I think I've got something working, and now we'll take what I've learned and put that back into my production code and strip out the old LORA code, and hopefully get back to testing. So that's what I got.
What's the new timing seem to be?
Well, the main loop the main loop runs at 100,000 hertz. So I get 1 million cycles in that main loop every 10 seconds. And then, I get 30 characters down and 20-ish characters back up. Basically once every, twice a second. So that, I think that'll be, the most latency sensitive issue for me would be like the e-stop. If I press e-stop, I want it to stop. And so I think that message would get to the tractor in, half a second.
Which equates to how many feet at full speed?
Yeah, I haven't done that math. Well, so if if 1.5 meters a second, I don't know what that is in feet, 5 feet. 5 feet,
2.5, 3 feet.
yeah, thereabouts. Stay away from the neighbor's fence.
At least at full speed.
Hmm. Yeah, the more dangerous thing is backing it into the garage, and with that would probably be the more prone space to screw something up.
It sounds like we're all got plans for the week.
I think I'm good.
Did you figure out what else you were going to tell us, Jeff?
No, but I just spent some time cleaning up that stuff I just posted to Slack. I cleaned up those messages and put a note on what they're for, so when people look at it, they won't be totally confused. I wasn't listening to most of what Al was saying because I was trying to do that. So it sounds like he's made some progress and he has to worry about smashing into things. Another thing that hasn't come up yet, I know Bob was saying he's got his radio control unit. So he's just got it's a VEX radio transmitter, which works just like a regular, like a airplane radio control system. It's just at the other end, it's got the receiver, has a single wire coming out, and it gives you the serial data stream of not serial in the term of characters, but it's got all your different little, if it's an 8-channel, you get 8 pulses all appended together. And that makes it real easy to decode with a microcontroller. And that plugs into, he's got a box, a VEX controller box that automatically figures that out. But the point is, he basically just has a radio control system. So if he moves his joystick forward, one of his new motor drivers he has will make the motor turn in a forward direction, and releases it. The motor just simply stops turning. So now you got to be careful doing that because say if it's connected to your transmission and you push the stick forward, the motor turns it forward, and the vehicle starts moving, then you release the stick, it'll continue moving at that speed. And then again, back to the concept, well, what if you decide you need to stop right now? Now you have to pull the stick back, and it'd be nice if it'd come back and stop at the neutral position, but it's not going to. So it's probably going to pull it back, and it'll slow down and come to a stop, and then start going backwards. And as soon as you start doing it, you're going to panic because it's not doing what it's supposed to. And he doesn't have the, if it was the full closed loop feedback, you push it forward, you're driving at some speed, and you release it, then the transmission will pull back to a neutral position and stop. That's not what he has right now. So you have to be careful about doing things like that. And the main reason is because, depending how fast it does this, if you push the stick forward, thing starts accelerating, and now you got this thing moving along at probably faster than it should be. And then if you notice you move something on your control and it doesn't respond like you want, you start thinking, now why is it doing that? I need to look into this. And the whole time your tractor's still moving, forward at probably a faster speed than it should. And then you realize, oh man, I'm screwed now. So now you start fiddling around with your joystick, trying to pull that back and get it to stop without backing up. So basically you get into a situation just by human nature, this thing is now out of control and you don't have any way to stop the thing. So that can be a problem. That's why you should immediately put some kind of e-stop on it. I don't know if he's got any kind of remote e-stop on it right now. So, but that's just more things, think through the steps and figure out what's going to happen. And in my case, I had it where I was driving my mini tractor down the sidewalk, and I noticed that, gee, the steering doesn't seem to respond anymore. And I went through the same thing about, oh, what could be causing that? What if I move this? What if I wiggle this around? And the whole time it's continuing to drive forward. And what I should do, or what anybody needs to do, is figure out, if it's doing anything at all that's not supposed to, slam that e-stop and make it come to a stop, and then go back and think about it. Because otherwise, my thing isn't big enough to do any serious damage like a lawn tractor would be, but still it's, it could drive out into the street, or it could run into somebody's car, or, whatever, it's just like Terry's damage on his vehicle. I could hit the neighbor's car and, put big scratches in it or big dents in it or whatever. So,
but I know you would leave a note saying that you did it, right?
Well, it depends how fast I can drive my tractor. Yeah, I suppose if you, well, since they're my neighbors, I probably know who they are. I could go talk to them, but yeah, that's an issue. And that whole thing comes up, you know, you need to stop and think through this stuff. You know, you can put it all together and say, yeah, I can move motors now, but then figure out, you know, what does that really mean, and try to rationalize how that's going to work, and how it's going to control, and what happens if anything goes wrong. So it's good to know all that stuff. Actually, on his, I think his Vex controller probably has some toggle switches on it somewhere. So you can have one of those toggle switches going to one of his RC servo channels, and the RC servo can just simply move you know, connect that to a switch. So it actually flips a switch on and off, you know, either to kill the engine or do whatever he needs to do. That's not a fail safe system, but it's better than having nothing at all to be able to do that. So I didn't think of anything else I was going to say, you know, that I said I forgot what I was going to say. I haven't figured out what it was yet. So
And sounds like we've completed today's tasks.